Hey guys, in this video I want to go over coercion and matrices and this video is meant to remind you that matrices can only hold the same data type. So let's look at an example. Let's say I have two vectors x and y and I create them here with the C function, and let's just put them in a matrix like we've done before in the previous video with the cbind function that'll put them column wise together. So x will be my first column, y will be my second column. When I run this code, I'm going to take a look at the class of the matrix, and then I'm going to take a look at the class of just the first column of the matrix here. And I do that by using the square bracket notation. Basically this says the square bracket notation allows you to reference rows and columns, and if you want you can select particular elements of a matrix, like this right here would be the first row and the first column. If you want the entire first column, you could just do this. So here's all the rows for the first column. That's what this square bracket notation is doing, and this is all the rows for the second column. And what these two lines do, they say what is the class of that first column in the matrix, what is the class of the second column in the matrix. So let's run this. Just going to highlight the code, press Control Enter, and look at the output here. So you can see here's my two vectors, x and y. The class of x is numeric, the class of y is numeric. That's correct. The matrix I create using cbind, here I print it out. Here it is. It has x is the first column, y is the second column, and then I print the class of that mat object, and it's a matrix, which we've seen before. And then I print the class of the first column, which is numeric, and the class of the second column, which is numeric. So this all makes sense. In this video I want to show you that coercion, which is something we've seen before, also applies to matrices. So if you try to do this, put some character vectors together with a numeric vector. So say I have, this is a character vector now. It contains two names. So y is a character vector, x is not a character vector. It's still numeric. And now let's print this out and see what happens. So when we run this now, x is a character vector, or sorry, x is a numeric vector, which is what we want. Here we are, x is numeric and y is a character vector. We put them in a matrix and it looks like this. X is the first column, y is the second column, just like we have seen the cbind function does. But now look what happens. There's these double quotes around all the numbers. So it looks like these are now characters, and sure enough, when we look at the class of the first column right here, it says that this column x is now a character. So everything in this column is a character, and that's not what we wanted. We wanted numbers here, right? So we passed in numbers into our vector x, and we passed in another vector y with characters. Somehow when we combined them into a matrix, everything came out a character. And if we scroll down, you'll see the class of the matrix, the class of that mat object is character. The class of both columns are character. And that's because, just like we've seen in other videos, the coercion of data types to the lowest possible class. So in this case, character, because you tried to mix a character and a numeric, R behind the scenes says, well, a matrix can only hold one data type. So it has to figure out the lowest possible data type it can convert both of these vectors to, and that happens to be into a character matrix. So just be aware of that, and you could do the same thing here with, if you do true and false. If you try to combine a logical vector and a numeric vector like this, and you run the code, now you're going to get a numeric matrix. And just like we saw before, the logical vector x here, this was true and this was false, they get converted to numeric values, because true is always represented as 1 or non-zero, and false is always represented as 0. So coercion still takes place when you use matrices, and it's important to remember that. It's important to remember that a matrix is made up of the same data type. No matter what you pass in, R is going to convert whatever you pass into the same data type. So most times you're going to be using the same data type for your matrices, like it's all going to be numbers, it's all going to be logical or whatever. But when you do this, you want to be aware that something's going to happen, and what's going to happen is like what we just saw in this video. It's going to coerce things to the lowest data type. So that's all I wanted to show in this video. If you have questions, email me or go to the website and email me.